Hi, I'm Kashi, and I'm a product manager here at Google working on the databases team. Joining me today are going to be Doug and Shashank, who are going to help me explain how Cloud SQL for SQL Server can be set up and provide value to yourself and your organization. And all the familiar tools that today you're probably using with SQL Server on-prem that you can also use with our cloud offering. We're going to kick it off talking about an overview of the different capabilities and features that Cloud SQL for SQL Server provides and some of the considerations you should have when setting up the service. Then I'm going to focus in on some more complex topics that we generally get a lot of questions about, such as replicated persistent disk and how that plays into our high availability strategy. Then we're going to hand it over to Doug and Shashank, who are going to share with you a demo about transactional replication and how to set that up. Finally, it's going to come back to me, and we're going to talk about kind of the next steps of where Cloud SQL for SQL Server is going and some considerations about everybody's favorite topic, licensing and pricing. Okay, so if you're not familiar, Cloud SQL for SQL Server is one of 3 database engines that we offer as part of the Cloud SQL portfolio. It was released to general availability early this year and provides a fully managed solution that will provide common tasks and reduce overhead, such as upgrades, backups, patching, and other key aspects to managing SQL Server. Today, we have SQL Server 2017, 4 editions that are available, such as Enterprise, Web, Express, and Standard. It's fully compatible with the tools that you're familiar with, like SQL Server Management Studio and PowerShell. And we can automate a lot of tasks via the APIs and G-Cloud commands, as well as the console UX you may be familiar with, just as you would with both Postgres and MySQL as part of Cloud SQL. We show this map every year, and every year it just keeps growing in terms of the number of zones and regions that are available. And the key takeaway here is that Cloud SQL is available in all these regions, and SQL Server is no different. So you're able to have Cloud SQL for SQL Server in any of the regions that you are located in that GCP is expanding to. And this map will just continue to fill out as GCP continues its growth. So what you see here is actually the Cloud SQL architecture that's common to all of our database engines. And I thought I'd take a minute just kind of diving a bit deeper so that everyone can understand what's actually going on under the hood. And so on the left-hand side, what you can see here is actually each instance has their compute engine VM, just like you would in GCE, that has a Cloud SQL image in a container with both SQL Server and on all of our management agents running on top of it. This includes everything that we use for monitoring, management, connectivity, and the like. Powering that, of course, we have our network layer, which is common to all Google Cloud products, as well as persistent disk for our storage layer. And so whenever we go and actually do a deployment of SQL Server, what we're doing is refreshing the container on top of the virtual machine, and then firing up kind of the underlying storage layer. You'll see in a few slides, I'm going to talk a little bit about how persistent disk is actually used for our replication solution for high availability. And it's important to kind of tie that back into the concept that you see here. So because we have this separation of the virtual machine on the compute engine and this storage layer, we're able to more easily move between virtual machines and do things such as live migrate across regions or in different machine types, change the characteristics or parameters of the machines themselves, and increase storage as well without incurring disruption to your instance. Now on the right side, this is actually the control plane that's powering all of Cloud SQL. And so we have our metadata servers that provide us the management capabilities to roll out broad changes across the fleet. And so when we talk about things like, common interfaces or any kind of new capabilities that we want to provide to all Cloud SQL customers, not just SQL Server customers, they're actually deployed on the control plane themselves such that they can be accessed by all instances. So talking about kind of what that deployment looks like and what that creation looks like from the customer perspective, I wanted to take a minute talking about provisioning a SQL Server instance in Cloud SQL. And so you'll notice if you've gone through this flow that we have the same machine types that you're able to do again for Postgres or MySQL. But if you're familiar with SQL Server, you'll know that it can take advantage of the full breadth and capability of the resources that we allocate to that machine type, which today is up to 96 virtual CPU cores, 624 gigs of RAM, and a 30 terabyte SSD. One key difference here is that SQL Server in Cloud SQL only runs on SSD. You don't have an HDD option. We found that there's increased resiliency and less issues by only providing that one option. Now, you can initiate the creation of this machine or a modification of an existing instance, again, via the console UX, gcloud commands, or our API, much as you would for any other Cloud SQL instance. Again, the most important thing here when you're going and creating that instance to make it useful is you want to seed it with your data. And so there's a number of different options here, one of which we're going to talk about a little bit later to actually use transactional replication to set up Cloud SQL as a subscriber and have that kind of active replication to bring in the data with minimal disruption and minimal downtime. But of course, you can always import into Cloud SQL as well. And so you can import .back native files and be able to seed your data that way as well offline. Now, I mentioned it before, but once your Cloud SQL instance is in operation, you have a number of different other options and parameters that you can set. One of which that we've always gotten a lot of good feedback from customers is about the ability to auto grow your storage. And so you don't have to pre-provision all of the storage that you need from the get-go. Once you do that import, let's say you're importing a 500 gig SQL Server instance, so a number of databases that way, you can set autogrow on the disk and then not worry about making sure you have the correct allocation for projected growth, 3, 6, 9 months down the road. Additionally, you can set a number of different options, just as you would with SQL Server on-prem. So if you're familiar with the command using the stored procedure for sp-configure, you'll know that you can set a lot of those same settings in our console and via our APIs with the different options that we allow under flags. That includes collation, which is now available as well. For high availability, we'll talk a little bit of a focus about how that actually works, but it's important to note that in order to really get the most out of Cloud SQL and really take advantage of our 3.5/9 SLA, you'll have to select a regional availability configuration and then make sure that you pay special attention to maintenance windows and kind of the appropriate time for us to make any changes. Cloud SQL will, of course, do its best to minimize any disruption, have maintenance events, happen as quickly and as infrequently as makes sense. But our first priority is, of course, always making sure that the service is both secure and highly available. The final point I wanted to touch on was the automatic backups. We get a lot of questions around how frequent customers can take backups of their instance for DR purposes, or if they want to then store them and restore them into other instances, either on other clouds or back to on-prem if they're running a hybrid configuration. So by default, you'll have automatic backups on a daily basis that you can set a window when you want them to actually occur. These are storage snapshots. So they're actually snapshots of persistent disk and should not incur a performance hit onto SQL Server itself because you're not using the database engine to take the backup in this case. For more frequent backups, you could, of course, set to automate a set of manual backups and use the APIs or use gcloud commands, depending how you want to interact with it. But then you need to manage the retention of those backups yourself. So with the automatic backups, you have a 7-day sliding window. With manual backups, we don't actually cap it. We won't drop any backup instances. It's more of a manual retention management experience. But when you log into the instance, you'll actually see a list of all of the backups that you've taken manual, and you'll be able to manage them from there as well. Of course, you could always export the data. We allow a full .back export as well, and you can leverage that in conjunction, of course, but that does leverage the SQL Server engine, database engine in that case. Next topic I wanted to touch briefly on was analytics. Folks that are familiar with SQL Server are generally interested in also using the auxiliary services such as SQL Server Reporting Studio, Analytics Studio, and integrations services all together with SQL Server. And the best practice that we found is actually running those services separately in Google Compute Engine. From there, it's very simple to connect to your Cloud SQL Server instance via VPC, and actually have a reliable and durable pipeline that you can create for any data analytics or transformations that you want to do. Native tools will continue to work as expected. So if you're using things like Query Optimizer, or you're using any other Microsoft products, you're more than welcome to continue to use those and just connect to that Cloud SQL instance, and it should behave as expected. Now, if you want to use a slightly different stack, of course, Google Cloud has a very robust analytics ecosystem. And so you can use tools such as Dataflow or Cloud Data Fusion, and just use a standard JDBC connection string to go and connect to the Cloud SQL for SQL Server instance and the specific database you're working with, and then set up a data pipeline in that manner. And there's a number of examples that we have those in documentation. And in that manner, you can bring that data into other destinations, for example, BigQuery, if that's something that you're interested and familiar with using for. And those integrations will continue to kind of deepen and become more robust over time. I'll talk a little bit more about that at the end. The third topic that I wanted to touch on, which is again something that near and dear to all of our hearts, and better to talk about this proactively than reactively if something happens, is security, of course. So Google Cloud prides itself on being a leader in the security space, and there's actually a number of kind of cloud-wide platform features and capabilities that we take advantage of in Cloud SQL, both to ensure consistency around all of Google Cloud services, and also because it is kind of a best-in-class solution that we want to take advantage of as well. So Google Cloud, if you're not familiar, encrypts both data in transit and data at rest. And so at Cloud SQL, we use that in lieu of TDE just to ensure that we don't have that double encryption that could cause a performance hit. As a result of this, though, we're also able to take advantage of customer-managed encryption keys, if you're familiar with that functionality, as part of our key management store. And so just as you would set that up for any other Google Cloud service, you can keep using that for Cloud SQL. It'll work just the same. In terms of connectivity, you have three options, and really I've ranked them here in order of recommendation for security purposes. So number one is private IP. If you're connecting to other resources in Google Cloud, this is actually the easiest and most secure way to connect and access your Cloud SQL instance in your SQL Server database. You can set that as part of your VPC or peer to VPC networks if you so choose. There's numerous step-by-step guides and quick starts in terms of how to get this done, and you'll get the best and simplest experience that way. Of course, this isn't always possible, especially if you're coming from a different environment or connecting from another cloud. And so for those cases, you may choose to use a public IP. And of course, that brings a new surface area of security risks and exposure. And so we provide the Cloud SQL proxy that I've linked to here. I definitely recommend using the proxy in conjunction with public IP whenever possible, because it will manage your SSL connectivity and settings as well. And it's also not going to require you to authorize any networks, which is another attack vector that we've seen increases exposure to your Cloud SQL instance. Finally, if you do want to take on the manual task of managing all of those aspects, you're more than welcome to use public IP. Those are available. You'll get an IPv4 address that you can go and connect to. And you can connect from anywhere in the world as long as you add your authorized network as well. The final point here is in terms of the login credentials. So today, if you use SQL authentication with SQL Server as part of Cloud SQL, we actually provide you a pre-cooked user, which is SQL Server. A bit different if you're familiar with using SA or sysadmin in SQL Server, and it is a subset of those permissions. We do this because we want to ensure the integrity and security of the service. And so you'll see, we have a list of functionality that's available on our documentation site in terms of what can and cannot be done by the SQL Server user. But the most important thing to note is besides what's not allowed, some of the T-SQL commands, such as the grant command, do have to use explicit syntax for actually, granting as customer roles that we define. And so I definitely encourage you to get familiar with kind of the syntax and the capabilities of this user as part of our documentation before you just dive right in. But by and large, you'll see most of the commands that you're familiar with should just work. So as I alluded to before, I'm just going to take a quick minute here talking about replicated persistent disk and how that feeds into high availability. So, this picture on the side here kind of serves the best purpose in terms of showing you the flow of what actually occurs. And so when in our high availability, it's a regional solution. So you have these two zones in the same region. The zones are, of course, separated as all of our zones are. And you have your primary instance here in zone A. Now, that primary instance is that compute instance I was talking about before, and that's joined to the persistent disk instance, which is located in the same zone. Now, those all are connected to that persistent disk instance, I should say, is connected and replicating to the zone B persistent disk instance, and they're always kept in sync by this agent. And so whenever you're writing to one instance, before that write, the write to disk actually succeeds, it writes to both persistent disk instances. Now, in front of all this, we have our IP address and load balancer that's actually governing kind of connectivity to the instance. So in the case where one of our agents notices that there's a heartbeat failure, the primary instance is unavailable, what will actually occur is that we will spin down that instance and switch over into that secondary zone where we've been writing to persistent disk this entire time. We'll spin up a new VM, a new container of SQL Server essentially, and join that to and mount that second persistent disk to it and reassign that IP address. So from an external perspective, there should be minimal disruption and actually no connectivity change because you'll be using that same IP address, same connectivity path. A couple important notes here. This is not using SQL Server's native capabilities, and so it's edition agnostic. You can do this with Web Edition if you so choose, or even Express, and have an HA configuration, which is sometimes helpful to keep your development environments, or if you want to really right size and go lean with your SQL Server instances, you're more than welcome to and still have HA capabilities with our SLA backing it. Finally, I just wanted to mention that typical times that we'll see here, we don't want too many false positives. So the heartbeat connection can take up to 60 seconds for us to actually determine it's a true failure or true unavailable, event. At that point, we'll initiate the switchover. Generally speaking, optimistically, you'll see it under another minute. Sometimes it could take as much as a couple minutes on top of that initial detection. So just a few minutes later, and you'll have that failover experience. And finally, I just wanted to call out before we switch over into the demo that SQL Agent is actually running on all of your Cloud SQL for SQL Server instances. And so you're able to create SQL Agent jobs just as you normally would. Moreover, all of the SQL Agent logs are written out to our operations stack with Stackdriver, if you're familiar with that. So you can set up monitoring and triggering just as you would with your on-prem solution. Now, let's go over to Doug Mahugh and Shashank to talk a little bit more about how this is done in practice.
Hi, I'm Doug Mahugh, and with my colleague Shashank Agarwal, we're going to show you how to migrate an on-premises SQL Server instance to Cloud SQL. This slide shows a typical scenario where you have an on-premises instance, you have an application connected to it, and we want to migrate the data to Cloud SQL without shutting down our application. So to do that, we're going to use SQL Server's data replication functionality. As Ori mentioned earlier, SQL Agent is enabled by default in Cloud SQL instances. And in the demo, Shashank is going to show you how to do this with SQL Server Management Studio, but you could use any tool that you're used to for database administration in SQL Server. Cloud SQL for SQL Server works with PowerShell, Azure Data Studio, whatever you're accustomed to. So you set up the distributor node to coordinate the transactions moving data from the publisher to the subscriber. In our example, we'll use the publisher instance as the distributor node as well, but in a production scenario, we'd recommend that be a dedicated GC instance in the middle. And once you kick off the migration, snapshot replication happens first. Now this could take hours because this is moving your entire database, all the history and everything, over to Cloud SQL. However, your application can continue running because those transactions are being stored, and those transactions will be replicated next, and you'll have an eventually consistent Cloud SQL for SQL Server instance that includes all of the transactions that took place during the snapshot replication. So this shows what's happening there. We're now migrating the individual transactions over to SQL Server in the cloud. And the final step is to just migrate your application over, change a connection string, point it to Cloud SQL for SQL Server, and now you're running in the cloud with all of your data migrated and no transactions lost. So now Shashank's going to show you step by step exactly how to do that.
I have a source VM which is installed with SQL Server database. In your scenario, it can be an instance outside GCP. This will be your source. It will be migrated into instance of Cloud SQL. I have pre-created a SQL Server 2017 standard instance. So let's get on with the migration. Let me RDP into this. So as you can see on this screen, I have already RDP'd into my machine, and I have restored AdventureWorks LT database, which is one of the sample database provided by Microsoft. And I would be using this database to replicate data into Cloud SQL instance. And I have connected to my Cloud SQL instance as well, and you can see there is no databases inside here. So first step to do this is to set up distribution. For convenience purposes, I am setting up distribution on the same node where the primary database lives, and this can be a different node as well. So once distribution has been enabled, I'll set up publication where I'm telling SQL Server to use transaction replication for my AdventureWorks LT database, and I'm then selecting what articles will be replicated to the target. So essentially I'm selecting all the tables. You'll notice that build version table is disabled, and this is because it doesn't has a primary key column, which is something to be aware about, that transaction replication does not work with non-primary key databases. And next, it's asking me if I want to filter anything. I do not. I'm instructing it to create a snapshot of the database to initialize the subscriptions, and then I'm providing the credentials for this distributor to connect to for this publisher to connect to the distributor. Since this GCE VM has not joined any domain, I am essentially supplying my Windows credentials for it to work. And then lastly, I'll provide a name of this publication. So once this publication gets created, we'll see this in the list, and next we'll add this distributor as one of the owners of the source database. So I have added distributor admin as one of the owners, and now we'll create a subscription. So I'm giving it SQL Server Cloud SQL instance as my subscriber to this publication. Right now I do not have any database in this, so I am instructing it to create a new database, and as this would be done, you would see a new database generated on the left hand side, and this would be a blank database at the moment, but as soon as this configuration is complete, then it will start replicating data into this newly created target database. And once again, I'm providing the credentials of my source and target systems. SQL Server, Cloud SQL Server offers connectivity using SQL Server login. So let me finish this. Once I will finish this, it will start replicating data, and we can click on this and view synchronization status to show what's going on. So right now it is saying it is starting the agent, and if I would go into my target database, I can see already the table schemas has been replicated, and if I would instruct it to select some top rows, I'm already observing that some top rows are already inserted into it. Now let's see how it is doing. So that would conclude our demo. Any further changes in the source database will be automatically replicated into the target.
Thanks, Shashank. And now we're going to go back to Ori. He's going to tell us a little bit about pricing, licensing, and what's coming next for Cloud SQL for SQL Server.
Thanks so much, Doug and Shashank. It was really great to see transactional replication live and see how to use Cloud SQL for SQL Server in practice. So now I'm going to talk a little bit about everyone's favorite or least favorite topic, pricing and licensing. It's really important to kind of demystify this and make it a bit more transparent. And that's something that we always strive to do here at Google. So breaking this down, Cloud SQL for SQL Server is really made up of three components when you talk about how we do pricing. So we've got our instance price, which if you're familiar with Cloud SQL today, both for Postgres and MySQL, there should be no surprises here. So you've got that same region-specific price that's comprised of core and memory. HA instances are going to be twice as much on the instance, mainly because we maintain those two instances to provide you that failover, so you have that standby secondary. And if you have watched any of the Cloud SQL presentations so far at Next, you'll know that we've now released committed use discounts. And so those are now available as well. And so if you choose to prepay, you do get a discount both at the 1 year and 3 year commitment levels, which can be fairly substantial. It's additionally important to note that that commitment is actually able to be used across all Cloud SQL products. And so you can go and use kind of your committed amount, both for SQL Server and let's say for Postgres, if you're interested in having applications that leverage databases of both types. Now, the unique part for SQL Server is, of course, the licensing. As a partner reseller for Microsoft, we do offer, the SQL Server license that we have to as part of our Cloud SQL offering. Now, the nuances here are very similar to what you see in Compute Engine, and so the license cost is charged on a per vCPU basis. There is a minimum of 4 cores, however, and so even if you run a smaller instance, you will have just the licensing component actually be charged at 4 cores and up. And this is, of course, varies by edition, with Express actually having no licensing cost in that case. BYOL, unfortunately, is not available for Cloud SQL, but it is available for Compute Engine. So if that is something that is a requirement for your organization, I definitely encourage you to go speak to any of the folks over with Compute Engine or reach out to any account manager or Google Support Agent, and they can guide you through that process. The final component here is fairly standard across all Google Cloud products. We have our storage and networking price. The interesting parts here for Cloud SQL are going to be how we charge backups. Backups are charged a bit different than capacity, and actually at a cheaper rate. But you'll see that kind of that same HA fee difference is baked in as well. And so you'll have kind of capacity being charged twice, but backups not. Now, finally, networking, you'll have ingress being free into your Cloud SQL instance, but I would definitely encourage you to take a look at kind of the egress pricing so there are no surprises, because based on how you expect data and traffic to leave your Cloud SQL instance, you may get charged more or less. So there's a bunch of tools online, a bunch of calculators and guides that will help you navigate and reduce any complexity there. So I want to talk just a brief moment about what's coming next. We're really excited here on the Cloud SQL team about what's developing in the service. So if you're not familiar, there's a number of sessions out there talking about the managed service for Microsoft Active Directory that we provide as part of Google Cloud. We showed this last year at Next in conjunction with Cloud SQL for SQL Server, and that's something that integration is actually coming very, very soon. So definitely keep an eye out for that. It'll be on, of course, all the typical blog posts and marketing channels that we provide here. Additionally, there's going to be a number of new high availability and DR options that we're going to be rolling out as well. And so I definitely encourage folks to keep an eye out for those in the coming period. Migration improvements, you've seen a little bit about how you can manually set up transactional replication, but we will be providing an additional, more streamlined functionality in conjunction with our database migration service that we've also recently rolled out as well. And finally, a deeper analytics integration. And so we talked a little bit about how you can set this up, connecting to Cloud SQL with Dataflow and Cloud Data Fusion to get to BigQuery. We're definitely focused around investing in that workflow and how we can kind of streamline that relationship. So for folks that are familiar with the Google Analytics ecosystem, you should have a much easier time moving forward of using Cloud SQL products like SQL Server alongside those tools as well. Thanks so much for joining us today and talking a bit about Cloud SQL for SQL Server. I definitely encourage you to check out all the other great content here at Next. If we're the first session you watched, thank you so much, and we're flattered. But there's tons more to see on the site. So check out the catalog. Here we've listed a number of sessions related to Cloud SQL. Now, beyond that, of course, we have a number of sessions if you're more interested on Microsoft on GCP in general. So as I mentioned, Active Directory has a session, as well as Compute Engine. And so lots of great content there, as well as our keynotes, of course. So definitely take a moment, browse the catalog, find more interesting content, and hear from more of our wonderful speakers. Now, we've also put together a showcase demo for Cloud SQL. I definitely recommend checking it out, and you can go and actually see in action a bit more about how Cloud SQL operates and some of the replication and the failover occurs. And finally, if you want to just dive in and get more hands-on, we have quick labs up for Cloud SQL at the link you see here as well. And so definitely recommend checking that out, trying it out, and seeing if you can navigate through all of the steps and start using Cloud SQL for SQL Server. And with that, I just want to say a big thank you from Doug, Shashank, and myself, as well as the entire Cloud SQL engineering team and all the other disciplines that we work with. It's a real pleasure to bring this service to you, and we really hope that you find it useful and enjoy using our service. Thanks so much.